none of us are really competing with each other. Right now, we are all competing with obscurity. Essential that we as builders, as developers in the identity space work together. Right now, the internet traffic is about 50% bots. That means about half of the content on the internet comes from unaccountable instances of AI agents and generative content where you can't tell if it's a human being on the other side of the screen. However, hospitals are beginning to form pretty unique relationships with startups and AI companies, where in exchange for an investment or in exchange for equity or upside, they will share patient data to train AI models or to utilize in these new technologies. At the end of World War II, one of the executives of IBM estimated that the world would only need 4 computers and that would be enough for global demand. You don't want to publish your home address on the most public database the universe has ever known. It would be more private if you put it on a billboard in Times Square. I firmly believe that the environments around us will respond to who we are based on what we choose to share, instead of an endless line of document exchanges. I think that you are never going to fill out a form again.
Welcome to the Upwind podcast, where we navigate shifts, knocks, and pivots at the intersection of technology, innovation, and impact. I'm Lily Dash, and today we're setting a course towards one of the most critical and rapidly evolving topics in tech: digital identity. When I think of identity, it strikes me as the genesis block of the blockchain ecosystem, absolutely integral to achieving the transparent, just, and accountable on-chain world we envisioned as a crypto industry. We're joined by Evin McMullen, founder of Billions Network, a groundbreaking platform redefining identity in the era of blockchain, zero-knowledge proofs, and AI accountability. Together, we'll explore how Billions Network is building the essential layers of trust and privacy, allowing humans and artificial intelligence to interact responsibly and securely in our increasingly decentralized digital world. Today, we'll talk privacy, personhood, and why AI might finally be ready to meet the real world responsibly. So firstly, I want you to tell me how you started in the space. Give me an intro of who Evin is, how you got here.
Sure. So my name is Evin McMullen. I grew up in a small town on a farm in Ohio in the middle of the United States. And when I was a student at Yale University, I wandered into a computer science class taught by, I think, the best professor on earth, a woman named Elizabeth Stark, who later went on to become a founder in the Bitcoin payment space. But at the time, she was our very cool professor. And rather than having us do problem sets or do long readings, instead, she would bring in new ideas and entrepreneurs to teach us about what they were building. And in the course of that exploration and learning about technology, entrepreneurship, and technical research, that's how I first encountered the Bitcoin paper. And so that was a little over, about 15 years ago at this point. My career after school wound through a variety of human-centered design practices, from technical content, working with teams like CERN and the Large Hadron Collider, helping to launch products like Watson from IBM in the early days of AI. I also worked with connected hardware companies, launching things like the first connected toothbrush and building vehicle-to-vehicle mesh networks that we now know as self-driving cars. I also spent some time working with another computer science professor of mine at Berkshire Hathaway in Omaha, Nebraska. And it was at that time that I got really excited about a new blockchain called Ethereum. So then began working full-time in crypto and in digital identity systems in 2017.
Whoa, that's so cool. So you started in 2017, but you started learning about cryptographic networks in school.
Yes, I did. And I also will say, if anyone is interested in these topics, some really awesome books to check out include The Future of the Internet and How to Stop It by Jonathan Zittrain, who's a professor at Harvard, as well as The Wealth of Networks by Yochai Benkler. And so, a couple others, Code 2.0 by Larry Lessig. Many of these books were published around the, 2000s, 2010s, and really started to explore what networked societies mean. What does it mean to have instantaneous distribution rails for your ideas so they can reach every person in every corner of the internet? And what does that mean for the expression of culture? What does that mean for the expression of value? So at that time, the academic setting of studying distributed systems and cryptography was really paired with these philosophical questions of what it means to us as human beings to have these available technologies.
What does it mean for the expression of culture?
For the first time in human history, you and I can have a conversation here, and that information can reach any person on Earth and in space with an internet connection for all time. We have created, through tools like blockchains and our modern internet, the ability to have public and permanent, censorship-resistant information distribution. This means that no single party can decide to stop you from sharing a message. And that message doesn't just have to include a conversation or video as though we're having right now. Those messages can also include digital money. Those messages can include proof of how old you are or where you live. And so this means that not only can we distribute ideas globally to audiences that have otherwise never been able to access them at this scale, it means we can do so cheaply, easily, and infinitely. And so we have eliminated the scarcity of distributing ideas. So what this means is that, in a cultural context, the cost of distributing your ideas is now lower, and the range of where they can reach is everywhere.
Wow, that's an epic answer. Okay, so one of my first questions. When I think of identity, it strikes me as the genesis block of the blockchain ecosystem, absolutely integral to achieving the transparent, just, and accountable on-chain world we envisioned as a crypto industry and community. Evin, how do you view identity in the context of blockchain's broader mission? And why is it foundational to building the type of decentralized future we've imagined?
So I think you are absolutely correct that identity, or the way that we refer to different parties, people, and participants in a network, is pretty crucial to interacting with one another. For example, when you go to a party, you usually introduce yourself with your name. You ask for the name of the other people you're interacting with and that you're meeting, and you start to ask questions about each other so that you can find common ground and have a conversation. But if the only thing I know about you is how much money you have, which is true of a blockchain, you can see those addresses and you can see what assets are connected to them or owned by them, then there aren't a lot of conversations or interactions that we can have. If you and I know each other's, addresses, whether it's email addresses or Ethereum addresses, we know the assets that we each hold, we can play two games together. We can interact in two ways. One way is that we can spend that money together. We can spend those assets. And second is we can do over-collateralized lending. But if we want to coordinate a discussion like we're having today, we want to build a product, if we want to create an application that's going to be safe for users of all ages on the internet, if we want to enable a business to be able to use this technology, we all need to know more about one another. And so that's why, to your point, identity, or how we refer to each other in a decentralized network such as a blockchain, is the very first step of being able to interact in that space. How can I talk to you if I don't know your name?
When we're thinking of, when I said it's like the genesis block of anything that we might want to do, obviously we know that from a cultural standpoint, from being able to share in this decentralized world, but what about from a real world perspective, like medical records or real estate records, ownership of real world assets, or?
Certainly. So let's dig into what we mean when we say the word identity.
Right.
So typically an identity, I think of that as a name plus information that describes that name. So that name, you might sometimes hear it referred to as an identifier. That can be a Bitcoin address, an Ethereum address, your legal name, an email address. And then the information that describes it could be the assets that you own, your age, your location, your medical history, your favorite color, or even your favorite pizza order. And so together, identity, the sort of name you go by, the identifier, plus information about that name helps you to show, who you are, what you can prove, and allows other parties to recognize that information and create personalized experiences for you. Whether that's determining what loan is appropriate for you based on your past financial history, or what to write on your name tag when you introduce yourself basically with your name in a new space. I think it's also important to note that, identity is not the thing. Identity is the thing that gets you to the thing. What I mean by that is no one wakes up in the morning with dreams of logging in, right? You're usually logging into an app because you're trying to accomplish some other task. And you have to introduce yourself to that app in order to enjoy the experience, thereafter. And so I see identity as a great enabler of many different types of coordination. You mentioned things like medical records and, we've got all sorts of financial, non-financial use cases, but in the context of the crypto and blockchain space, usually identity starts with a crypto address, a wallet address, and some assets, some potentially financial assets that are held by that address. So what we at Billions Network are working on and making possible is the ability for these otherwise pretty simple addresses to express that full range of data in a secure, safe, and legal way.
How far away do you think we are from really being able to do that in a super secure, safe, and legal way?
I love this question because before we get to that, I want to rewind for a quick second.
Okay, sure.
So when I started working on digital identity systems in the sort of more traditional consumer tech space, usually what we would do to build up data around a user's identity is that we would capture that data from their internet actions, from their use of devices like toothbrushes, and we would end up with this tangle of APIs, all these different sources of information, and then it became really difficult, slow, and complex to try to untangle them and make sense of them. Then when I started working in the crypto space, it became clear that an easy way to let you bring your data from one place to another, instead of having a bunch of business logic on the back end that's trying to move it around, would be simply for you to carry it from one app to another yourself, for you to be the transport layer for your own information,
right,
to be able to bring it from one place to another. But this gets us to the questions of security and cost. So back in 2017, if you wanted to add some identity data to your Ethereum address, let's say, it was really expensive. There were network fees that cost a lot of money if you wanted to add that data in a public way that would be able to use these global distribution rails. So much so that you might be paying $100 every time you add a piece of data. And that's just not scalable for thousands or even millions of users. Then there's this other part, privacy. You don't want to publish your home address or even, something like your favorite color necessarily on the most public database the universe has ever known, where, like we were talking about earlier, anyone on Earth and in space with an internet connection can access it.
Yeah.
That's probably a little more publicity than it needs, right?
Yeah, literally universally accessible.
Exactly. It would be more private if you put it on a billboard in Times Square. And so then we were posed with this question. How can we create and use identity data, like your age or your location, associated with your address in this very public way in a manner that was going to be safe and would also comply with the law? Because there are laws in a lot of different places. You certainly know better than many of us that establish guardrails around whose data you're allowed to share where, And these laws specifically, often protect things like personally identifiable information, so like your name, your home address, as well as information about minors, kids who are under the age of 18 or under the age of 13. So there's this technology called a zero-knowledge proof. A zero-knowledge proof allows you to prove something about a piece of information without seeing it. And, in jest, I like to call that mathemagical. It's a way that we can use cryptography to learn about someone's identity or information without actually revealing it. And so it's these types of tools that allow for us to do exactly what we've described, to use blockchains to be able to manage this data, but do so in a safe and compliant way. But the problem at that time was that you would have to sit at a desktop computer for about 30 minutes waiting for this computation to produce a little proof that then you would have to pay, sometimes $100 or more to publish on a blockchain. And so obviously that's not the type of experience that we want to enjoy when we pull up an app on our phone, right? Waiting that long time, having really expensive fees, having to click about 1 million times in order to make that happen. And so in the ensuing years, some of my incredible, brilliant teammates decided to tackle this challenge and have now improved the way that that technology performs. So what that means is that today, the Billions Network makes it easy for you to prove traits about yourself in a private and secure legal way in less than 2 seconds directly from your phone. So you could do it on the go in an Uber on your way to the next stop. Another set of technologies that have made this possible are cheaper and faster blockchains. So those fees, in order to make that data available and use it in these network environments, are now a few cents, even fractions of a cent, or in some cases even have no cost at all. So over the last few years, we've definitely seen the underlying tech improve to the point where now, today, in the year 2025, we can enjoy these technologies. And actually, in about a week, the Billions Network team will be launching our new native application, where you'll be able to do things like take your passport, tap it to your phone, pull all of the data safely out of the NFC chip in that document, and then create zero-knowledge proofs to prove to apps that you're over the age of 18 or that you're from Barbados without revealing what your birthday is or the name of that country.
Wow. Did we, just for the listener, just in case they didn't catch the meaning, to really bring it home, like the meaning behind a zero-knowledge proof, do you want to just go over a quick definition? A
zero-knowledge proof has 3 core components to it's the way that it functions. The first one in the name is zero knowledge, meaning that I can ask Lily to prove to me that she knows what's in that box while I have no ability to see inside of it. So zero knowledge means that I do not know. I have zero information about or knowledge of what is inside the box. So I cannot see what's in there, but you can prove to me that you know. The second one is completeness. This means that as long as Lily has the secret to this box, that has the secret key, any question I ask her about what's inside the box, as long as she has that password or secret key, she can always prove it every single time. And then the third is soundness. This means it can't be counterfeited. Lily can't have a fake password that will somehow allow her to give the right answers. And so with these 3 elements, we are able to learn about information without revealing it in a way that we can use math to prove that it is correct every time.
Wow. Okay, so let's go back to the passport situation.
Actually,
go ahead.
Sorry. Real quick, just one little thing I want to jump in there. Just another little history lesson here that I think is super cool about zero knowledge proofs.
Go for it.
So, some of your listeners might be familiar with this professor, Larry Lessig from Harvard, who coined the phrase "code is law," and wrote a few great books, including Code 2.0. And in the year 1997, I was 7 years old. In 1997, Professor Lessig suggested that in the future, you will be able to go to a bar or a restaurant, somewhere where you need to be of a certain age to enter. And rather than handing your ID card to the doorman, who would then see perhaps your organ donor status, your home address, your eye color, instead of giving them all of that information.
Your age,
your birth date. Instead of giving all that information, there would be some mystical, magical, future technical math way to prove that you are old enough to enter that establishment without revealing all that information. 1997. And so today in 2025, we can finally do it. But anyway, let's talk about passports. Sorry for getting us a little off track there, but I love that example.
You just answered that. So basically, the math, the code is able to answer the questions regarding your passport without having to answer the questions about your passport.
Precisely. So if we think about that box with a lock that you've got, right? That's sort of how our application works, where you can take your phone, tap your passport to your phone, and then we take the information from your passport and put it inside of a locked box on your phone. And then, because you have the secret key, you control your phone, you control that passport, you control the app, and we, Billions Network, are mathematically prevented from seeing that data. You can then create zero knowledge proofs in only a couple seconds on your phone to prove things like the fact that you're of a certain age, that you live in a certain location, or that you are not on the terrorist watch list country.
Wow. Okay, so what does the technology look like for just future, going into the future? What does the technology look like for a nightclub or the technology for an airport in the future?
So in the future, but also today.
Okay, fine.
Yeah, no,
Next.
this is great. This is really exciting because we are really in the very first months and years of these technologies breaking their way out of the lab into our lives. So what this can look like moving forward, I think, is that rather than handing your entire passport to the doorman at a nightclub, you can pull up your phone, scan your face to unlock it, and just pull up a QR code. And the bouncer can scan that QR code and it'll give them a thumbs up or a thumbs down. Lily's allowed in here, Lily's not allowed in here. And so it almost changes the question that any doorman or airport security person or app login will ask. Typically and traditionally, the question is, what is your birthday? Or what is the trait or capability that allows you to enter this space? And wanting to know exactly what that is. And instead, the new question is, are you qualified to enter this space? Not asking for your birthday, but a simple yes or no. Either you meet the criteria or you don't. And so that means we have to exchange a lot less information to be able to accomplish the same actions. That means it's going to take less computation, less time, less cost, less complexity for us to do what we were planning to do anyway and get on with our day and save a few minutes in the process.
But also with more integrity, because think about how many fake IDs and fake, are created for those nightclubs, for those 17-year-olds that want to go out.
And I'm not going to comment on the extracurricular activities of the youth here. But what I will say is that you make a really great point about counterfeits. In fact, recently I saw that a number of folks have begun using, AI, generating image tools to create false legal documents, false receipts, false passports, or pictures of them that look pretty convincing. And so when you have an NFC chip embedded inside your passport, that NFC chip that carries the information in your passport actually is signed and sealed by the government who gave it to you. So if you imagine, kind of like if you were to receive an old school letter with a wax seal on it, right? You know that it came from a certain audience. You know that they enclosed it so that, so that it would be clear that it came from them. Similarly, that's what's happening with your passport, where when the government puts that NFC chip in the document, they have a special cryptographic key, a public key signature that only that government passport office uses. And if the file that comes out of that passport is not signed by that specific government, then you know it's fake.
Yeah, these chips. Okay, so I read that you have a super extensive ZK library with like 9,000.
We've got like more than 9,000 projects building on top of our zero knowledge libraries, sometimes referred to as ZK, the cool kids. But these libraries include CIRCOM, Rapid Snark, Snark.js, and our team are stewards of these open source and publicly available libraries. And, as you mentioned, there are a lot of people worldwide who are using them because they are so well established and so secure. In fact, for students in universities around the world who are learning about zero knowledge technology, typically these libraries are their very first stop to get started, to learn about how these tools work, and to start creating simple applications.
Wow. So your library, your billions network libraries.
These libraries actually have a pretty long history of development.
Okay.
As with any popular and well-hardened tool, they have evolved over many, many, many years of research and gradual improvement. We were talking earlier about how, back in 2017, doing this stuff was really slow and really expensive. And now today it's really fast and really cheap. And that is largely due to the continuous and, focused continued development of improving those, which we continue to do to this day. And so now they form the foundation of projects that we've built on top, and including and most recently the Billions Network.
Wow. Okay, can you just break it down? A ZK library, like what is in the how does a ZK library, is it a ZK library of books?
Oh my gosh, that's a great question. So typically, when we discuss a piece of code that can be picked up and used inside of an application, you might refer to that as a library.
Okay.
And so zero knowledge, code libraries, such as those that we've talked about, are basically sets of code that an app builder can pick up and drop inside of their app to be able to produce zero knowledge proofs. And the nice thing about these libraries and about some other tools that we've built is that it takes the guesswork out of cryptography for everyday app developers and builders. Usually if you're building a website, you're building an application, that means that you may be familiar with, some different, software languages, but you're probably not a really experienced cryptographer. There certainly aren't a lot of those folks floating around, and very few of them are building, friendly applications for people like you and me. And so that's why it's really important for us to have clear and secure, friendly tools that take the labor and complexity and difficulty out of this very high performance, capability, and make it available for everyone really easily, from students who are learning for the very first time to global institutions that serve the international financial markets.
Okay, I'm going to ask like a technical question-ish. When it comes to medical records, would a medical management software company look to the ZK library?
I love this question. So actually, back in 2017, when I started working in crypto full time, this was the very first project that was brought to me. How might we enable patients to control their medical data and to take it with them from one hospital to another? How might we allow a person who's just gotten in a car accident to immediately retrieve and share their vital medical information and medical history with paramedics on site? How can we lower the switching cost of being able to move that information from one place to another so that many physicians can coordinate care for an individual patient without having to play phone tag with each other all day to try to share that patient information.
Yeah.
Now, the tough thing, you mentioned, these electronic medical providers. The tough thing is that companies like that, such as there's one in the United States called Epic that is, very popular across the market. Those companies make a ton of money installing their very complicated systems. In fact, Epic is written in a special code language called M, which at one point cost about $300,000 per line of code to write.
Wow.
And sometimes these, installations, these setups at hospitals and care facilities can be thousands, tens of thousands of lines of code. And so that's a pretty high cost that they've got and a reason that they want to own and control that data and limit the extent to which it might be taken out of that system. So it is a moat of stickiness. It is less likely that that the hospital, the service providers will change the way that they're storing their medical records if it's such a pain and so expensive to migrate to a new system. Now, there are a bunch of new laws and evolving regulations that help to transfer some of that power back to patients and suggest the right of egress, or your right or ability to request your medical data and to take it with you. But the challenge with some of these opportunities is that if you receive all of your medical data in a giant PDF, what on earth are you going to do with it, right? It's got to be pretty difficult to sort through, to sift through, to find the information you want, to share it in a way that's going to be easily digestible by a new service provider.
Yeah.
And so really, just in the past few years, we have finally started to see instances where zero knowledge proofs can make this possible in a medical context. One example with our tech stack at Billions Network is that we actually work with a group of clinicians, physicians in Europe called Top Doctors. We make it easy for them to be able to prove the identity of their patients, to be able to aggregate data across dozens of clinics, and to be able to do so using zero knowledge proofs as the way to protect that patient identity while still delivering super high quality care and accurate information. We know that information is accurate because we are relying on math, not on trust or on someone's good behavior or on a special piece of hardware that's going to confirm that data for us.
This topic of identity is a big topic, right? Like, you really have to understand and cryptography to begin to wrap your head around it. In that case, with the doctors in Europe, how are they doing? How are you able to empower them to identify their patients in a zero knowledge proof way?
So a friendly app on your phone.
Okay.
In the same way that when you log into your email on your phone, you log into a social network like Instagram or like Twitter, you've got a username and a password. You might use Face ID. You might use another method of interacting, such as a hardware key or a YubiKey. And then once you log into that app, you just use it like normal. And the nice thing about the applications that we enable are that most of the technology is invisible to the person using it. And from a physician perspective, the data and access that they have is only to the information that they need. So it's organized and structured in a way that they're able to use it. But on the patient side, all of that, personally identifiable information that cannot be transferred from one space to another can still be proven to exist. But the nice thing is that, from a user perspective, you really don't notice very much that's different in the app, other than that when you log in, it happens pretty quickly. And suddenly there are all of these new functions the app can do that it couldn't do before.
Right. Okay. So in this instance, you might have a patient and some medical records, and maybe it might hide a piece of their name or...
Yeah, it might hide their name. It might hide their home address.
Right.
It might hide, in fact, all of the information, that might identify them specifically, but you can prove that it is a specific patient.
Right.
And one other thing, just on the medical data front, that I think is pretty wild, is that as we had noted before, there are all sorts of laws, like HIPAA is one in the United States, that prevent the inappropriate disclosure of your health data. So that's, reason, for example, that doctors can't put your blood tests on their website as examples to share with the world. However, hospitals are beginning to form pretty unique relationships with startups and AI companies, where in exchange for an investment or in exchange for equity or upside, they will share patient data to train AI models or to utilize in these new technologies. Now, it's pretty cool that there are large research hospitals that are at the forefront of this tech, but it's also pretty scary when you start to look at the way this data changes hands to help these fledgling companies and participate in these experiences. So despite HIPAA, we've seen, and it's been broadly publicized, examples of, for example, hospitals taking non-anonymized patient data, so things like x-rays or blood tests, putting them into a folder, attaching them to an email, and just emailing them directly to a company.
Wow.
So not
That's
utilizing
totally
secure
illegal.
channels and not utilizing best practices around security. And so there are plenty of problems that we can solve by using better technology, but poor decisions around security are a human problem, not a math problem.
Now that we're clear on the ZK libraries, can you tell me, what's the origin story of Billions? I know that we spoke briefly about it originally, but I just wanted to go over that.
So the origin story of Billions starts as a little bit of an idea and a frustration. Okay. When I was working on connected devices, home hardware, and cars in more of a traditional setting, where it was really difficult to figure out how we were going to personalize an experience with a device based on information about the person who was using it. And all of these data privacy regulations, data security and localization laws made those types of setups really complicated, really expensive, really, really, really difficult. And then, of course, blockchain technology came along and seemed like a pretty cool, interesting coordination tool, a way to be able to manage data about many different parties, all coordinating together, all communicating together. But, we had to overcome some cost and some complexity to get there. Then, one of the sort of interesting challenges around that type of coordination is that, when you look at the design of Ethereum, it was not built to prove things like how old you are or the fact that you hold a passport from a certain country. But that information is essential if we want to, for example, create KYC or know your customer, legally compliant financial experiences that banks are allowed to participate in, that regulated entities are legally allowed to touch. And so, initiating this work, as we had talked about, before, is part of a technical challenge, but also part of a business challenge for the readiness of blockchains to be able to serve more than just financial interactions. So back in 2017, some of my now colleagues, co-founders, and researchers were in the city of Barcelona in Spain, and began cooking on these projects, these problems, these, improvements to zero knowledge proofs, to cryptography that would allow us then later on down the line to build these tools. Around that time, I started at a company called ConsenSys in Brooklyn, New York, building out a blockchain called Ethereum, and working on these very early identity tools, as well as spending time here in Dubai, where we are right now, where I helped to open the first office and one of the first sort of formal blockchain practices that was here in the city. And around that time, we began speaking with government entities, with enterprises that started to see this opportunity with identity. What if, instead of carrying around a paper copy of your passport, you had a digital proof where you could prove the traits from that passport on any website, in any physical space, in any application? And it was around then that I realized that, I needed to focus entirely on this specific problem in order to build tools that were going to be appropriate for everyone around the world, because there really wasn't a ton of industry focus on it at the time. So in 2022, I founded a company called Disco, where we believe that you are the multifaceted center of the party, just like a disco ball, just as you are, and that the world should revolve around that identity. Like the party revolves around a disco ball so that you can reflect your identity and your traits to the world however you decide. So with Disco, we invented the data backpack, which is the first web app where you could carry around data about you using your crypto wallet from one app to another. After a few years of development on that, it became very clear to me that our friendly application and design and interface needed a deeper tech stack with more robust cryptography so that we could handle the serious data like we've talked about from government IDs or data that's appropriate for legal compliance with things like banks. And so last year in 2024, our team was sort of acquired by, merged teams with a practice called Privado ID. This team had initially been incubated inside of the Polygon blockchain ecosystem and was sort of the research hub and evolution of all of that cryptographic work that began so many years ago with some of my now teammates. And so it's sort of the end of the rainbow with that epic union of our two teams, bringing together, consumer-facing and application layer expertise, multiple blockchains in our repertoire, combining that with a really strong cryptography and protocol engineering team. Thus was born, out of our work together, the Billions Network. And that's how we got to now.
Wow. You're so passionate and enthusiastic and knowledgeable. It's so inspiring.
This is a privilege. I pinch myself every morning when I wake up and get out of bed, usually with not quite enough sleep, because the opportunity to build in this space is so vast. And the technical problems that we have in front of us are challenging, certainly, but really we are building human coordination tools here. And so the most difficult, the most interesting, the most inspiring part to me is that we work in the service industry. We are serving human beings with these tools. And now with these global distribution rails, we can bring that equally to everybody.
Yeah, wow. Another term I like to use is systems of organized effort.
Ooh, that is a beautiful phrase. Wait, tell me more about systems of organized effort. Like, how do you think about that as a concept? Like, how did you come to see it that way?
No, I mean, that's just systems of organized effort. I mean, that's what we're all striving towards, right? The most efficient systems of organized effort. That's how the world was created. That's how Dubai was built. That's how the crypto community with 100K Bitcoins was created, systems of organized effort. And the more organized we become, the more successful we become, the more lives that we touch.
I really like that. And I also there's something kind of funny about a blockchain network and the organized effort that it involves, because we talk about blockchains as technologies, right? They are write once, never erase databases. They're really good at creating timestamps, and they are enabled by many different computers around the world, all working together in coordination as this human coordination tool. But that requires many human beings to coordinate around those computers. It requires many human beings to update the software on those computers so they continue to work together correctly. It requires the people writing the code for that software to not make mistakes when they push it that could take down the network, which has happened before, It also requires that, the folks who are taking care of the edges of this network, the computers that make it up, not spill coffee on their machines, that they pay their electricity bills, and that they do so in a manner that is, consistent and regular to keep that network alive. And so as much as a blockchain is a human coordination tool, it is also made up of humans, because it cannot exist without the massive coordinated effort of all those individuals and then the computers that are, acting on their behalf.
Yeah, exactly. So much effort. Oh my gosh. Over this last decade plus. You spoke about challenges, right? What you have clients or you work with or you provide ZK libraries to clients like Deutsche Bank, right? Mm-hmm. Or TikTok, yes. Which is what I read. What are the challenges of your experience working with these like off-chain IRL companies? And bringing value to them and like bridging that gap between where they were and where they are now.
That actually,
where they can be.
Yeah, the perfect description of what the task of a product is, to bridge the gap between a future state where things are operating better, faster, more cheaply, more easily, and the setting where we are right now. So, when I first started working in blockchain technologies, it was often my job to go meet with the leaders of countries, to meet with the CEOs of large companies and enterprises and explain to them, what is a blockchain? How do you use it? And where can you use it to get a better business outcome than you have today? So kind of bridging that gap. Now, the challenge, of course, is that a lot of these technologies came out of pretty academic environments. Mad scientist labs of inventors who were building on the fringes of what is mathematically possible, not necessarily thinking about how easy it would be to make those tools accessible to the average app developer at a bank. So our role with Billions Network, my role really over the years, has been that of a translator. How do we go from, inside of the mad scientist mathematical laboratory and out into the Forbes 500 list, enabling better business outcomes? And that's really the translation between research and product. With many of these folks, of course, education is the very first part, but they're not as much interested in, the intricacies of how you made it as they are understanding what it does and how they can use it to achieve better business outcomes. So in the ensuing years, it became really clear that not only do we need to teach these audiences about what blockchains are and how they work, we need to understand exactly how costly, how complicated, how intensive it would be for them to adopt these tools. Because if you don't think about how difficult it's going to be to change to the system that you're trying to get to, if you're only thinking about how much better it would be if you use that system instead, then you're not really thinking about the full life cycle of what it means to upgrade or the change management process of bringing a new tool to market. In fact, in the 1990s and early 2000s, we saw exactly this with the internet, that a lack of understanding, led to a lot of companies being confused as to why you would want a website. And in the early days of e-commerce, there were a lot of folks who thought it was pretty crazy that anyone would ever want to buy something on the internet with a credit card. And this skepticism, this lack of understanding when you talk about the tech and not about the business outcomes, ranges back as far as human history and technology has existed. In fact, sort of another funny example, at the end of World War II, one of the executives of, I think it was Hewlett-Packard or IBM, estimated that the world would only need 4 computers.
Wow.
And that would be enough for global demand. So that's kind of where we started in educating many of these businesses and governments about blockchains, is that they thought of them as, novel and interesting objects, these cool new technologies, but couldn't really understand why you would need a bunch of them or what would be beneficial to, their operation out of them. And so in the ensuing years, we've seen a lot of work, and we've certainly done a lot of work to basically make those solutions really easy. So for example, with partners like HSBC, with Deutsche Bank, we've worked with them to make it easier for them to serve one another's clients, or to be able to serve their own clients in multiple jurisdictions around the world, where the privileges of those clients, those people who are banking with those entities, those privileges that they had as a customer would be modified based on the country that they were accessing it from. Now, it seems pretty simple, right? If I am banking with one institution, I fill out a bunch of forms to tell them who I am. I should be able to continue to interact with them and not have to reintroduce myself. I've already filled out a form that told you my name and where I live and who I work for. And so why on earth do I need to do that every single time that I get a new credit card? Every single time I want to open a different type of account. And for businesses, this can be even more complicated. I've got some investor friends and colleagues who have to fill out forms to reintroduce themselves to their banks like 4 times a week. In fact, in the United States, Americans spend, I think, more than 50 million hours a year filling out forms. And so when we work with partners like, JP Morgan, like Deutsche Bank, like HSBC, we think about what are the business challenges that are really frustrating to their customers today. Where is there human error that's causing problems? Where are they spending more money than they really need to? And how can we cut down on those complexities by providing them with a solution where they don't have to be super experts on cryptography? They just need to drag and drop a few lines of code and insert it into an application or experience that they already like, that they just want to improve a little bit.
Wow. Yeah, it seems as though ZK proofs are just integral to any real world application that we might ever need.
It makes my little heart sing to hear you say that. And a few other cool people who I think agree with you include Google, who just released a really broad, sweeping effort around zero-knowledge proofs to help to integrate this technology into their practice. Yeah. Also includes folks like the European Commission. We recently, Billions Network, and our team and tech stack was selected by the European Commission for the European Blockchain Sandbox as a place for us to demonstrate things like age-based access control. So making adults-only applications or child-safe environments on the internet using zero-knowledge proofs to prove how old you are, instead of having to submit a copy of your passport to some random website where they're going to keep a copy of it in order to make sure that their users are of age. And right. I know that sounds like kind of a goofy example, right? Why would a website, some random website, want a copy of my passport?
Yeah.
But that's actually already happening in multiple places in the United States where content websites that are only appropriate for adults to access have to prove that you as a user are old enough to be there. And instead of just ticking a little box that says, I am over the age of 18, you have to submit a proof of age document. That could be like a utility bill. And so then we've got all these little websites, these startups that were not built to store utility bills and passports. They were built to distribute videos or to create interactive chat content or AI tools. And so the cost of operating your business can be way more expensive, way more complicated, way more risky if you have to figure out some manner to comply with these laws and you don't have tools like zero-knowledge proofs to make it easy.
Yeah, it almost seems in a way like futuristically impossible otherwise, because if you think about how e-governance is evolving, and definitely everybody struggles with cybersecurity, right? Even the greatest nations with the most amount of resources struggle with the burden of cybersecurity. In this instance, you're taking that burden away from them because they don't even have access to the knowledge.
That is actually a really, accurate way to describe it. Often our team is called in to modernize digital identity systems for governments when the form that they're using is not sufficiently secure.
Right.
And
exactly.
They want to be able to deliver better resources and services to their citizens.
Right.
So, for one example, there are a lot of digital identity systems that, nation states use, similar to passports, where you might have a national ID number. And that number is associated with your name.
And everything else.
Yeah. And
how much tax you paid last year.
Exactly. All of the information that the government has about you. And it's basically just a giant spreadsheet. with a bunch of numbers next to a bunch of names. Now, in the early days of digital identity, that was pretty cool, pretty radical, that, that you could have this ID number, you could associate it with your name, but it's very limited because you can really only use that in contexts where the government has easy access and verification, or someone is just willing to trust their eyeballs instead of actually double checking that it's accurate. It also creates what's called sometimes a honeypot, or a really valuable set of data where the cost to hack into it is lower than the value you will extract when you get inside of it. And so we have seen examples where, insufficiently secure national identity systems have leaked private data of more than, at this point, 1 billion citizens on Earth.
Wow.
And this is, governments trying their very best to do a good job with security around identity data.
Barbados, you're not alone.
Yeah, it is, startling when you start to see all of the instances in which a lack of security around identity data can bring harm. And we know plenty of historical examples of this, whether it is the public disclosure of someone's race, someone's religious affiliation, someone's, medical status, that making that data, available to parties who would do people harm can end in some really bad consequences.
The concept of deep trust is central to your platform. Can you explain how accountability for AI is encoded in your technology?
Certainly. So we've thus far been talking about identity for human beings, but let's get into identity for AI. Right now, the internet traffic is about 50% bots. That means about half of the content on the internet comes from unaccountable, some of them AI, instances of AI agents, and generative content where you can't tell if it's a human being on the other side of the screen. If you've looked at your Instagram comments, your Twitter comments recently, you've probably seen some amount of that non-human activity.
For sure. And
this means that, we are rapidly losing trust in the internet, that we can no longer believe what we see with our eyes. And this is additionally true with generative content created by AI. I'm sure you've probably seen images or videos before that seem really realistic, but you can't actually tell whether they're, modified or whether they were really taken by a camera or some combination of the two. And so if you can't tell who is on the other side of an interaction, you can't tell whether they're human or not, then, you've lost a lot of trust and you're going to be really skeptical about whatever you see on your screen. But human beings are not wired to mistrust our senses, to mistrust our eyes.
True.
And so the internet today, with, half of that traffic coming from bots, is asking us to mistrust our senses in order to safely go online. And that is just not scalable, not sustainable. And it's also, plaguing the online economy as a massive drain of resources. So one of these, challenges is that accountability requires identity. What happens when bots do bad things? It's not as though you can, send them to timeout, or you can discern necessarily which entity was associated with them. And while this is, a constant challenge for malicious actors, it's also a problem for good actors also. So, a recent example of businesses trying to embrace instances of AI agents to improve their products is an airline in Canada. Air Canada had incorporated a little chat window using ChatGPT.
Okay.
So the customers could ask questions about plane fares and basically almost like talk to a customer service agent.
Okay.
So a little more mature, a little more, probabilistic of outcomes than something like a chatbot, but also a little friendlier for everyday users. Now, the challenge is that airline did not tightly control the model, the instance of the model that it deployed. And so that little chat interface began making up airplane tickets that didn't exist and selling them. And so this, of course, is a massive risk for a business, if you have an instance of an AI agent that is producing content that, that you could not anticipate, is not in the bounds of your business, and now, you have to owe up to it. You are beholden to making good on the commitments of your product because you controlled that website, you own that product, you are that airline. This actually went to a lawsuit, and the airline lost. Because it was so evident, your website was the one producing these plane tickets. You have to honor them. So this opened up a big thorny question. How on earth do we manage risk and identify these instances of AI agents? Whether it's for insurance, for basic accountability, or for, making sure we can buy our plane tickets correctly. So this takes us to deep trust. This is basically an approach that our team, Billions Network, created to assign a unique identity to an instance of an AI agent, just like we as humans have unique identities. And then we make it easy to associate that AI agent with a specific human being, such as the person who built it, the person who controls it, or a group of human beings, such as an organization, a business, a collective of developers. So this sort of premise that accountability requires identity first requires us to identify the humans and then to identify the agents they interact with.
So the account, it's all on the human behind the AI that created the AI.
I think at the end of the day, accountability for businesses and for human beings always comes back to a person or an entity.
Right.
And this is especially important if we want an AI agent to act on our behalf, right? So if you imagine
certainly in the case of Air Canada, of course.
Like if
there's a legitimate expectation to those clients that they would have received that plane fare for that price.
Certainly.
Legally.
And, and you also imagine that if you're interacting with that airline's website, that it is in fact information coming from the airline. So this is sort of this kind of assumption or question around identity that gets a little bit more complicated when we imagine, you and I have digital butlers. Now we have our AI assistants, right? Our AI agents that may be able to, in the very near future, do things like book plane tickets for us or order a hamburger for us to enjoy after this podcast.
Or like outside drive us around.
Exactly, or drive us around. But then there's this question of agent-to-agent interactions, meaning how does my digital butler know that it's talking to your digital butler? There is no way to ask an AI agent, take me to your leader, because there's no name tag on it. There's no, set of information that tells you where it came from in a standardized way. So not only is this an issue for safety, it's an issue for coordination. If we want multiple agents to be able to interact with one another, they need to be able to discover who they are, what privileges they have, and define the workflows that are going to be permissible.
Super interesting, the rabbit hole, especially when we go to decentralized autonomous organizations and the fact that potentially an agent might be able to spin one up or can spin one up.
Absolutely. Yes. So, organizations also have identity, and organizations are usually made of people. But now they can also be made of agentic workflows that are created by people or even by other AI agents. So that's why another element of the deep trust framework is a reputation model for agents.
Right.
To be able to add data to each other's identities based on the interactions that they have, so that they can build reputation over time and make it even easier to discern how to coordinate and which to trust.
Assigning persistent identities to AI agents raises ethical questions. How do you ensure responsible management and governance around this?
So right now, the ethical nightmare that we are in is that there is zero accountability and zero way to discern, in a standardized, scalable manner, who an agentic counterparty might be related to. In fact, in the crypto space, we see a number of malicious actors, both human and non-human, across the blockchain doing bad stuff all the time. So the challenges and questions that arise when we start implementing these identities, I think pales in comparison to the hot mess that we're experiencing right now.
Hot mess.
Absolutely. But also, when we start to open this question of what does it mean to assign an identity to an instance of an agent, right? That also implies something about how that identity is structured. The information that you include is inherently opinionated. And so I think that, starting off with use cases where that agent identity is really focused on a specific business outcome, such as performing a financial trade or moving capital from one space to another, that these types of very clear, mathematically precise, kind of simple interactions are a great place for us to start, so that we can initiate these interactions, we can, see them evolve, understand where the guardrails need to be before we go ham on all sorts of use cases for which we may not understand the externalities. And so, my approach to that question would be slow and steady, to start with business outcomes as a useful set of initial examples, and to really try to, abide by those guardrails of improving business outcomes in a really clear way.
Yeah, it's hard.
We set no small goals. We wouldn't be here if this was easy.
Yeah, no, this particular one, this is a real naughty knot to untangle. But yeah, of course, think about all the hours you're going to save humanity when it's solved.
I'm hopeful that not only will we save, many hours in total, but also like a few seconds off of every frustrating interaction that you have.
Compounded. Annually,
every single day, forever, improving in perpetuity.
Among 9 billion people.
Yeah, and that's why we're called the Billions Network, because we are here to serve the billions. Not to, limit the access of this technology to a privileged few, but rather to extend that freedom, that additional time, resources, and capability to absolutely everyone.
If everything goes well, when everything goes well, what does the next 5 years look like for humanity once you've been able to achieve what you set out to do?
So, Lily, 5 years from now, I'm going to invite you back to Dubai. And the only thing that you're going to bring with you is a device of your choice. Maybe it's a phone, maybe at that point it's a Neuralink. But you are going to be able to go through the doors of your building, into your ride share, into airport security, border screenings, health screenings, through your plane, onto the other side, to your, hotel, and then to the place where we meet, without ever filling out a form, without ever pulling a piece of paper or document out of your pocket. I firmly believe that the environments around us will respond to who we are based on what we choose to share, instead of an endless line of document exchanges and inefficient processes. I think that you are never going to fill out a form again.
Wow. Never going to fill out a form again.
And I think we are also going to invert the labor of search, meaning rather than typing words into Google to try to find, a new couch for your home, you instead will be able to represent where you live, the type of couches that you like, how much you want to spend, where, that couch is going to go in your house without disclosing that specific data. And you will be able to receive many recommendations through zero-knowledge technology for the perfect couch, without revealing data about yourself to advertisers or allowing them to harvest more information than is necessary for that exchange.
Wow. Allow them to harvest more information than is necessary. I mean, they can harvest so much now.
They can.
Apparently legally.
And it's also becoming a business liability for them. Because we talked a little earlier about honeypots and the amount of effort and time and security that's required to store a ton of sensitive data. This is especially becoming difficult in places like the European Union, the state of California, and the United States, with data privacy and protection laws that require citizens are able to contact businesses and ask them to delete or remove data that pertains to their person. Now, as we also discussed earlier, these businesses were not built to go back in their records and remove data about specific individuals. They may not even know how they've used that data over the years if they've held it for a decade or two. And so the cost and complexity of managing this data is actually becoming wildly expensive. In fact, there are, many small businesses in places like California that maybe only have 6 or 8 employees, and 1 or 2 of them are devoted to responding to these legal requests to manage and remove certain pieces of information from the database. Like, it is just so wildly expensive and inefficient, and it creates a huge risk if you're storing all this data that someone's going to try to hack into it and use it inappropriately, which is then, a liability nightmare in and of itself. So the principle of minimum disclosure, or sharing your data on a need-to-know basis, disclosing only the information that's required to get the job done, instead of sharing, with the doorman the fact that you're an organ donor, instead giving him a thumbs up that you're allowed to enter. I think that principle of minimum disclosure will not only be more economically productive for businesses that are collecting data and using it, but will also be more secure for the systems themselves.
Yeah. Okay, I just want to talk one more about the zero knowledge proofs. So when we think about like ChatGPT, to your knowledge, is there zero knowledge proof embedded in ChatGPT, or?
So, all right, let's go back to the 70s at Harvard.
Okay.
Right. So there's this professor who was working on one of these early instances of basically like a chatbot, right? And at that time, software engineers, coders, were basically all women, which is pretty cool.
That's super cool.
And this professor's, assistant had compiled, put together the code to create this chatbot. It was called Eliza. And so, she types in, all of this content and creates this experience where you can ask questions and receive answers in human language, not unlike the experiences that we have with ChatGPT today. And so, obviously this woman understood very well how Eliza came to be, right? She wrote every keystroke herself. And yet when that professor walked over to the desk and asked her what she was doing as she was chattering away on her keys, she covered up the screen and said, "Professor, please, this is private. I'm talking to Eliza." And so that impulse, right? That impulse for us to share, disclose, and exchange in natural language when we are talking to or typing into an interface has been there, basically as long as computers have. And that's certainly true today. I think, interfaces like ChatGPT or Perplexity are now playing host to some of the most intimate questions that human beings have, some of their most personal and intimate ideas in a manner that is, much more exposed than they might necessarily interact with something like, Google or looking in a book where you're not leaving a trace of what that question might have been. So what's particularly weird about these black holes of information is that they are constantly consuming your questions, consuming your contents, and then using that information in some instances to train better responses that are more personalized to you. Very cool, but also very weird if you do not know where that data is going or how it's secured or what other parties might have access to it or how else it may show up in your life. So we do not yet know the consequences of this, this sort of new way of interacting that humans have found with friendly AI interfaces like ChatGPT. But I, certainly hope that there will be more focus on user control in these systems. We've also, started to see interesting examples of AI tools that are built with more privacy and more security than the average platform. So one that I'll call out, certainly not perfect by any means, but I think an improvement above many is called Venice.ai.
Okay.
It's founded by a gentleman named Eric Voorhees, who was, very early in the Bitcoin ecosystem, and also, led the development of a project called Shapeshift. And so has been instrumental in a lot of frontier technologies for many years. But Venice.ai is sort of similar to ChatGPT, but has many more of these privacy protections and capabilities built into it.
Super cool. Venice.ai.
Yes.
Okay. another question.
Yes.
Obviously, I have more questions than the
All
two.
I want to do is answer
Than
your
the 2
questions.
hours
These are great questions.
permit. But okay, when we think about WorldCoin and these other identification systems, do you see them as a competitor, or do you see them as a partner? Do you see them as part of the ecosystem? That how do you feel?
I think of projects like WorldCoin as colleagues. Since the early days of their work, I've actually had the privilege to speak with them, to meet with them. I even went into their offices to to see how the orb is made, and then have given a ton of feedback on papers, documentation before it goes out, because none of us are really competing with each other right now. We are all competing with obscurity, and so it is essential that we as builders, as developers in the identity space, work together, that we, provide rigorous and honest and respectful feedback to one another so that we can all improve, because we all are working in the same service industry in service of human beings. Now, sort of simply put, I think of WorldCoin like a proprietary camera company. They make a special kind of camera that takes a particular kind of picture and produces a specific type of data. But sort of unlike their model or their approach, Billions Network, we have a very flexible approach to identity, which means that you don't have to start with a special camera to get on board and to start using Billions Network. We've actually integrated with more than 100 different government systems. We've integrated with many different providers of trust and data. So our sort of flexible framework allows for there to be these many, many different sources and authorities, proven authorities of trust, as opposed to just one. Now, as long as there exists more than one country, more than one company, more than one type of camera, more than one type of phone, I believe that being able to incorporate these types of data together is going to get us to the best outcome. And we've already started to see government systems, agree. It's unfortunate that, teams, out there in the space have ended up actually getting banned, sanctioned, fined, kicked out of countries because they are violating the law and not being safe with user data. In many of those places where others have made those choices and gotten kicked out of the countries, we are with Billions Network, we're actually openly welcomed places like the European Union, places like the country of India, or even right here in the UAE. And so we find that rather than trying to compete with governments as an alternative form of identity, we work hand in hand with those governments to modernize and improve the identity systems that they have.
Got it. Okay, so personally, what do you think about the biometric identity space? Like, do you think it's sustainable based on the way that our technology is rapidly evolving? You mentioned Neuralink before. Do you think that it's a sustainable means of identification, like these special cameras or these biometric palm readers? Or
I don't think that they're sustainable alone. And part of the reason for that is that your biometrics can make a cool username, but they make a terrible password. What I mean by that is, like, for regular operational security, you usually want to change your passwords, fairly regularly. And you can rotate a password that you type into a computer, but you cannot rotate your thumbs.
Or your face.
Right? Or your face. You can't swap out. I mean, maybe you could swap out and get new eyeballs. I don't know. But certainly, actually, yes, the ability to have transplants exists, just for the record. But that's not scalable, like you said.
Right.
So in order to have control over your identity, to decide, which aspects of yourself you're going to use to prove and control that identity, and to do so in a manner that is globally scalable, I think we need a little bit more of a sophisticated approach. If we think about something like, for example, verifying human uniqueness, proving that Evin is different than Lily, there are basically 3 ways to do that from kind of a data and technical perspective. The first way is that we could use soft tissue biometrics, right? We could use fingerprints, we could use iris scans. But one of the challenges there is that it's pretty expensive and difficult in order to do that at scale. So, for example, with cameras, you sometimes run into something called a collision, where a camera will take a picture of your eyes, take a picture of my eyes, and accidentally think that they're the same eyes. Or, I might be looking at that camera from a different angle than I was before, and it might not recognize me. Anyone who's ever used Face ID on an iPhone knows that, if you're particularly sleepy and you're trying to unlock your phone, sometimes it doesn't recognize your face. And so biometrics alone can be expensive, difficult, require specialized hardware, and just aren't particularly scalable alone, especially in, the broader internet and, outside of very limited physical environments. So the second way to differentiate that Lily and Evan are different people in this group of people is that you can just have a list. This is like what government IDs look like. So you've got a government ID number, a name, maybe a photo of you, and that combination of information can discern us and determine that we're different. But the holy grail of this, verifiable identity space and being able to differentiate human identity is what we call the web of trust, or the ability to combine multiple sources of data, multiple authorities, and the information that they have about you, or that they can share or prove about you, to determine that the data that describes me is so different from the data that describes you that it would be impossibly expensive for us to fake it and show up as the same person. And so we call that the cost of counterfeit. So the more unique and provable, verifiable data that you have about your identity, and the more differentiated it is from mine, the more clear it is that it would be unreasonably expensive for us to fake that data, and therefore there is an economic incentive to honesty.
Right, just like the Bitcoin blockchain.
Oh, amen.
You spoke about your face not being able to be, you can't change the password of your face. We could change the password of our passwords, and we have to do that often. When it comes to such sensitive information, like hospitals, airports, like we can't afford to ever be able to hack this information. And you just said, yes, it needs to be more expensive to hack it than it is to leave it alone, essentially. In the age of like quantum and the future, how do you feel? How do we avoid any potential risk in that regard, or manage any risk in that regard?
That is a spicy question, right? In the race between hardware and math that is, moving forward at breakneck pace on both sides, how do we maintain a safe equilibrium?
Right.
How do we ensure that the cryptography that we use to secure our networks today is not broken at a large scale in the future?
Yeah.
In fact, challenges such as this have led to some really interesting research around starting with zero knowledge proofs, but actually leading to even more sort of sophisticated and secure methods of what's called obfuscation, or hiding or obscuring data in a way that it can still be used. So the sort of next generation or next kind of concept from a zero knowledge proof, where you're just asking a question about a specific piece of data, right? That locked box that Lily has on her lap with that one insight in it that you want to learn about. Zero knowledge proofs are great for individual pieces of data that are at rest. They're not changing, and you're, referring back to them. And then the next step is called FHE, or fully homomorphic encryption. And that means that you may have a lot of data, a whole set of data, many boxes worth of data, all that is encrypted, all that is obscured from you. And you can not only ask questions about it, you can perform math on it. So you can, for example, search to see how many times a specific word shows up in a file without seeing any of the content of the words in that file. So that's fully homomorphic encryption. Homomorphic encryption is just a method of being able to obscure and encrypt data. And then kind of the third generation, the wildest edge of this is called IO, or indistinguishable obfuscation. And with I/O, basically you have a computer program where you can't see the guts of the program. The program has a secret key, its own secret password. And it uses that secret key to sign its output, so that when you look at you sort of ask a question to this program, you receive the answer from the program, you know it's signed by the program, so execution is equal to validation. You know that if it executed and produced data with this signature, that it executed correctly without ever seeing the process of what it was doing. So this is sort of the bleeding edge of capabilities of, sometimes we also refer to things like blind computation, or being able to derive insights from a large group of patient data without ever seeing any of that data to discern patterns in likelihood of or comorbidities of diseases. It's like one example that we've already started to see in the medical space. So the challenge, sort of uniqueness of quantum computing is that it threatens the integrity of many encryption systems. And so in that race to improve cryptography and to further secure these networks, I think we are well ahead of a place where I would be concerned in any way. But it is also a wonderful promise that we can make these networks even more performant, as opposed to simply being concerned about the integrity of our keys.
Great answer. Thank you again. Okay, so what's next for Billions? Like, you have you've already partnered with 100 different governments around the world, right? There's like only 198 in total. So you're like more than halfway there. You've got 9,000 projects under your belt. Like, where to next?
So where to next is the App Store. Obviously, our privilege of working with governments and enterprises means that often our technology is behind the scenes, quietly enabling better experiences, but not necessarily living front and center in your life. We realize that these technologies should be accessible to absolutely everybody, or at least as many folks who we can reasonably scale it to without needing to wait for government entities or for businesses to be the very first to introduce it. So I actually think next week we will be launching the very first version of the updated Billions Network application. You can go to billions.network if you want to pre-register and get kind of signed up and ready. With that application, you'll be able to do things like we talked about earlier, tapping your passport to your phone, creating privacy-preserving proofs of age or location, and you will also be able to receive rewards that are personalized to your identity in the form of tokens and benefits. So actually seeing real financial value by asserting who you are without disclosing any of your information. So we're very excited to bring that experience to a friendly and light touch space, and to help demonstrate what this technology can do for everybody without anyone having to learn what cryptography means. We currently don't have a token, but we do find that there are a lot of folks in the blockchain space whose projects are creating tokens. And often those projects will experience something that is called a Sybil attack.
Right.
Where, for example, if a project's launching a token, they plan to distribute that token to members of their community, some of those people might create multiple accounts to try to obtain as much of that as token as possible.
Of course.
And some projects are totally okay with this, but some projects care very deeply and only want, each person to receive a specific amount. And to not allow any one person to have, 50,000 different accounts that are all receiving that benefit.
Yeah.
And so in order for us to prove the uniqueness of every user, to make the distribution of things like token allocations or volume-based incentives in the financial space possible, we make it really easy for projects who are planning to launch a token to add a quick step in their website to check the unique humanity of every user and to make sure that only the appropriate allocation of incentives or rewards is given to each person, no matter how many accounts they may have created.
Wow. How do you, it just sounds like magic, like David Copperfield type stuff. How do you do that?
I told you, mathemagical. So literally the exact same experience that we talked about. You could start either from a website, inside of a website, or from
like
a native
IP
application.
Like tracking IP addresses.
So, IP addresses can be a way to determine identity. But for example, what if you and your sister are in the same house, or you use the same computer?
Yeah.
You're different people, and you may have different accounts, but some of that indicator data may or may not be accurate. And so the experience that we offer is really simple and straightforward. You can take, government document, tap it to your phone, prove that you're a unique person, to that application in a couple clicks in a couple seconds, and that's about it. So we could also prove that you are a live human being. So within that application flow or on your desktop computer, some of our partners want to make sure that they are giving tokens or incentives to human beings and not to bots. And so they have a little camera pop up.
Right.
And being able to utilize multiple inputs of data, including a bit of a live video feed, then you can combine that information to get a pretty likely assurance that there is indeed a live person on the other side, or a live person who's a different live person than the last user who went through this flow. So again, it's, zero knowledge proofs in action, used for a business process that will allow these companies to achieve better outcomes, more economically successful outcomes than they had before.
Do you want to just do like a walkthrough verbally of what your app looks like, potentially, and then I can pull it up and edit it in, or...
Cool. Yeah. The only challenge is I don't know when it's going to be out in the App Store, because when you submit
it's okay. We can also time this so that it's...
Oh my gosh, you guys could be the ones to launch it. I love that.
Awesome.
Okay. Yes. Done. Sold. You are the exclusive Billions Network podcast launch partners for our application.
Thank you. That's such an honor.
Done. Actually, I can send you a demo of the interface.
Okay.
Just so you can kind of see it. But yeah, the simple experience with the Billions Network application is that you can enter the app with your email address like you would normally. Click through on the little Google logo if you don't feel like typing stuff in. And then on the back end, we make it really easy to create a secure environment in your phone. So just you feel like you're opening up a normal app, but what has really happened is we are using the cryptographic security on that device to create a special protected space. Then you can take a document like your passport with an NFC chip, and you simply tap it to your phone. So you can kind of scan that image of the passport, tap that NFC chip to your phone, and then your phone actually has an NFC reader inside of it that is able to extract or pull out all of that data from the NFC chip on the passport. Then that application in the secure environment will double check which government entity signed the data from that passport. So it has sort of a cryptographic signature proving that it came from a specific passport issuing entity, such as the United States of America. Then once you've checked that signature is accurate, now we have all of the relevant data in this secure environment, and you can create a zero knowledge proof to prove that you are over the age of 18 to an app without actually revealing what your birthday is. Now, to you, for example, that might just be a couple clicks on a website. Or in the instance of an airdrop, you might prove that you're a unique person. But again, that's just a couple clicks through, really simple and friendly experience. And so for the most part, all of this technical complexity that we're talking about, zero knowledge proofs and underlying encryption, doesn't really get exposed to the user. You are just using an app and, proceeding as you would normally, but on the back end, you have the most secure infrastructure that the human history has ever had at their fingertips.
Wow. This is so cool. Like Zoom was hardwired onto the Samsung, before they started, before they got huge, but every Samsung came with a Zoom app.
Is so cool. And it also, I think really Samsung has been a global leader in native applications on their mobile devices that lead to, better experiences and bring in a lot of this leading edge tech. I also think that applications that are default on your phone are some of the best distribution rails and the friendliest way to put these tools into people's hands. So exactly like Zoom, I'm looking forward to, a day not too far from now where we will natively enjoy these abilities in our devices, and we won't have to download special apps, or we won't have to click through different websites. They will just already be built into the places where we spend our time.
That's amazing. Built in in the way that Bluetooth is built in, or built in the Billions is an app on the phone when you unbox it.
Samsung team, call me. We would love to natively enable all of your devices with these capabilities. And in the short term, if it's easier, we're happy to put it in the App Store.
Awesome. Okay, you said you wanted to do a little wind up?
I just wanted to say thank you so much for being so generous and thoughtful with your time and your questions, Lily. It has really been a pleasure to get to know you this week and to share more about our work at Billions. And for those who are watching at home or tuning in later on, I want to invite you to come explore what we're building to get started yourself. So you can always find us at billions.network. If you are interested in what we're up to, what I'm up to, you can find me 24/7 on Twitter. My handle is @ProvenAuthority. And my name is Evin McMullen, CEO and co-founder, and I will see you all on chain.
Thank you, Evin, for sharing your invaluable insights on building a trusted, secure, and privacy-focused digital future. To our listeners, thank you for joining us on the journey to the windward mark, where innovation meets impact.